So the big piece of meat in this update is the payment protocol, but we're actually going to save that until the end because it's probably going to be a longer conversation than these other elements. Things that might make it into 0.9, but that they're working on right now and that might also not make it, depending on how things go. So the first is no wallet mode, Bitcoin-CLI. This is again quoting from the article. Bitcoin D is increasingly being used as an edge router, used as a firewall between the full Bitcoin peer-to-peer network and some custom wallet or mining software to filter out any invalid blocks or transactions that might tickle bugs in the custom software's implementation of the Bitcoin protocol. The 0.9 release should contain Jeff Garczyk's -disable wallet mode, which lets Bitcoin D run entirely without a wallet, making startup faster and using it less runtime memory intensive. We are slowly moving from a monolithic codebase that does everything, wallet, RPC, network, blockchain storage, validation, towards more modular internals with fewer dependencies between the different pieces. Another change you should see in the 0.9 release is moving away from the Bitcoin D executable, functioning both as a server and as an RPC client.
What is RPC?
A remote procedure call. There is a application programming interface sitting above Bitcoin D that allows you to access all of the Bitcoin internals, like give me this block, give me this transaction, sign this transaction, send this transaction. All of those commands are remote procedure commands. So Bitcoin D gives you an abstracted API into the Bitcoin's ecosystem that's very easy to program against. The vast majority of clients that sit on top of Bitcoin D communicate with it using this simple API.
Adam hasn't read this yet, but it says the RPC client code is eventually going to be removed from Bitcoin D.
It's put in a separate executable. So basically a lot of this is about modularizing and containing these things into their own systems. The problem is that right now Bitcoin D is one big hairball of code. Let me clarify that. It started off as an enormous big hairball of code and has gradually been getting better and better in terms of modularity. This is great news because if you modularize these components, it allows other systems to re-implement them, to replace them, or to only run the bits that they need. And that will spur a lot of innovation. It also means that there's a lot less dependency on having the full and complete reference client for anything you need to do, and will allow you to gradually perhaps move to a more multi-platform, multi-client system.
Okay, that makes a lot of sense. I just have one more question. Why would somebody want to run the Bitcoin client without running a wallet?
Actually, I run the Bitcoin client without a wallet all the time. So, for example, if you're running a payment service, you don't necessarily want to have the wallet on the node that's processing transactions from the outside, which is facing the internet. You might actually have two Bitcoin implementations. One that's simply acting as a node on the network, passing information back and forth. It's your gateway into the network, an edge router, as Gavin put it. The other thing is that the Bitcoin D system is the de facto reference client for validating transaction. A transaction reaches consensus if all the current versions of Bitcoin D says it reaches consensus. So the only thing you need to know as a developer as to whether consensus happened is, does the Bitcoin D thing like it? Great. Then it's acceptable. That means you have to run Bitcoin D to do all of the transaction validation, but you don't always want the wallet on the same system for security reasons. This allows you to separate from a single-tier monolithic application that does everything to making a multi-tier application, having an edge router that's Bitcoin D that only does node work. Then you have an RPC client that's sitting further inside the network, can only be accessed from internal systems and gives you a programmatic interface. And then way in the back of the network, protected with firewalls, you have the wallet application that isn't running any of the other things and only handles wallet functions like signing transactions with keys. And that gives you three tiers. You have nice separation of functions, and it's good for security, it's good for performance, it's good for scaling.
You can also kind of think about it like the way that Apple used to do their hardware relative to the PC market that we know today. Right now, the way that Bitcoin D is set up, you can buy a computer or no computer, but what we're moving towards is a system where you can, buy RAM or buy, a different monitor, buy various things that allow you to take that technology and integrate it with something else or create something yourself and then build on top of it using the parts that you want, as opposed to just having the option of having all or nothing.
Yeah, the problem with the all or nothing is really nothing isn't an option because you cannot do anything on the main network without referring to Bitcoin D's validation capability. So effectively, if you did anything, you did everything. It was always all. And that was a problem. You had to take the Bitcoin D and run everything in one place. Now, most people would do that with an empty wallet, which is better than having a wallet with money in it, but it still means you're running all of the overhead of the code. Plus, if there are bugs in that code, you're now exposing it to the internet to be exploited. The less code you expose by turning it off, the better.
Plus, for the average user, I mean, I run Armory Wallet, and I have to have a copy of the Satoshi client running in the background because it was simply so much easier for them to just use the existing client for that type of functionality connecting than it was to build it into their own system, because there was a lot of complexity with that. Additionally, what they're talking about isn't the only implementation of Bitcoin out there. There's another one called Libitcoin that hasn't seen a lot of distribution, but is in the final stages of development, that Amir Taki's been working on for the last 2 years, that basically already does this, already has looked at the problem and said, okay, rather than having one monolith construct, we're just going to build from the ground up the idea that all of these things are individual modular pieces that can be plugged together as you see fit, but that ultimately each one is its own separate piece. So it's good to see the core development team catching up with this and moving in that direction too.
Yeah, and in fact, it's really important because even if you have competing options which are more modular and better designed, in order for these competing options to remain relevant, they have to follow the main reference client in every quirk and every bug from every block from the Genesis block 0 in August of 2009 to today. Every bug that was ever in the client has to be replicated precisely so that you validate in exactly the same way and arrive at the same consensus at the end of all of these blocks. That means that when you had to adopt the client and you had to adopt all of it or none of it, essentially it was killing innovation and development of alternative clients because there's too much work to try to keep up with a moving target. Modularity will greatly help the cause of a multi-client Bitcoin network.
Andreas, that bug comment that you made there, where every bug has to be replicated because everything has to reckon back to that one Genesis block. Is it possible to make retroactive changes to the Bitcoin system? Like if we wanted to affect, transactions that happened a year ago, is that even possible?
Not really.
Okay.
Well, you could if you basically arrived at consensus to ignore what's in the blockchain or ignore certain transactions. And there are bugs. For example, in the blockchain, there are transactions that really shouldn't have been validated and should never have made it into the blockchain, but because there was a bug in the client, they did. And now, in order to validate that transaction in the future, you have to reintroduce that bug or simulate that bug in every future client so that when it reaches that broken transaction, it behaves exactly like the broken client did then and accepts it. So you have to repeat the mistakes of the past in order to arrive at the same consensus of the present. That's a problem. We have to reincorporate all of the bugs. Now, another way of doing it is checkpointing. And this comes to the next topic in our list, which is the headers first parallel download chain sync. But essentially what we're looking at is summarizing parts of the blockchain and being able to operate faster with a smaller part of the blockchain so you don't have to replicate everything.
This one is entitled Headers First Parallel Download Chain Sync. And there's some text here, but the idea of Headers First Sync is to download the blockchain in 2 stages. 1, download just headers from your peers, which is very quick because each block header is just 80 bytes. And 2, once you've got one or more chains of block headers, pick the one with the most proof of work and then fetch the full block for that chain. So basically, this is trying to make the initial onboarding process, right, where you download the Bitcoin client for the first time, and you have to go through that. Right now, it's like a 1 or 2 day process, depending on how fast your connection is to the network.
1 or 2 weeks.
It's now several days because it's already reached 15 gig.
Oh, really?
Yep.
So that's what this is an attempt at, though, right? Is trying to take that initial problem of having such a huge amount of data that has to be downloaded before a user can even make their first transaction on an actual wallet that's on their computer, is trying to make that a much faster experience that's more efficient, right?
Yes, I think the best way I can describe this is that while Bitcoin's network looks very much like the BitTorrent network, because of the constraints of the blockchain, the fact that in order to validate a block, you have to have the previous block for its hash, etc., we haven't been able to really fully exploit the BitTorrent-like capabilities. You can't just go out and connect to 100 nodes and download the blockchain parallel from all of them, because you'll end up with multiple blockchains, and including ones that have been orphaned and various other things. And you can't figure that out until you've downloaded everything. So what this proposal does is it allows you to incrementally download parts that are required for validation, the hash of the block header for example, and then not download the bulk of the transactions inside until later. That means you can validate all of the chains up to today in terms of consistency and continuity. You still don't have all of the transactions that are in the past, and you can then incrementally download those, and you can get them from multiple clients because now you have one unbroken blockchain. You can just ask anybody for each one of the blocks. You know it's the true one. And that means you can now start behaving a bit like BitTorrent, going out, asking lots of nodes and getting a much increased bandwidth of return data. So this is great news. It will greatly increase the speed with which new full nodes will bootstrap into the blockchain, and we'll be able to start processing things much faster.
In our current system we have, then there's no parallel downloading. Right now, when you're downloading the blockchain for that first time, you are literally downloading from a single node out there?
Not necessarily from a single node, but you only download one block at a time. You start with block 0, which is encoded in the source code of your client. You already know what block 0 is. It's in every client. It's encoded statically in there. So you start with block 0. You say, okay, who's
so it's just chronological.
It's chronological. You have to bootstrap. Now, today, what you would say is, give me block 1, and you download the entire block with all of its transactions, validate it, and add it to your chain. Then download block 2. Now you can say, give me all the headers for all the blocks from 0 to blah, calculate the chain, and then start downloading transactions later. And then you could potentially parallelize that function and seek out from many nodes, many different blocks simultaneously. It's like making the edges of the puzzle first. So then once you've got the edges of the puzzle and you know what shape and size it is, now you can start filling in the center much faster. And you don't need to follow a specific pattern anymore.
Right. So this is different than what something like Electrum does, which is kind of like pick a checkpoint, kind of sync the blockchain after that point. This is not ignoring portions of the blockchain. It's basically just making the outline of the puzzle, like you said.
Well, yes. And in fact, the Electrum client as a lightweight client delegates its processing to master nodes that have the full blockchain. It doesn't keep a copy of the entire blockchain. It, in fact, doesn't keep a copy of any part of the blockchain, just checkpoints. What this is a full node, but one that bootstraps faster. It's not a lightweight node.
Hi, this is Jason King, founder at Sean's Outpost, and you are listening to Let's Talk Bitcoin. Sean's Outpost is a homeless outreach in Pensacola, Florida, and we are proudly powered by Bitcoin. To date, over 13,000 meals have been fed to the homeless in our area, all purchased with Bitcoin and through the generosity of the cryptocurrency community. Read more about us at seansoutpost.com. Food, shelter, Bitcoin, everybody. Sean'sOutpost.com.